Hello and welcome to Algebra II with Mr. Clausen. Today we are going to talk about a technique referred to as completing the square. And what we're going to look at today is we're going to look at examples of how to solve a perfect square trinomial, some applications with that. We'll look at a technique referred to as completing the square. This is really going to be a technique where you go and you set up trinomials, or quadratics I should say more specifically, to solve by completing the square. We'll look at how to combine skill 1 and 2 to solve an equation, and then we'll also look at an example where we can rewrite an equation in Vertex form. So that's kind of a quick synopsis of what we're going to look at today. So specifically what I want to do to get started here is I just want to show you some of the practical application of using perfect square trinomials. So what you want to be able to do with a perfect square trinomial is that if you see a perfect square trinomial, which is what this is right here, this is a perfect square trinomial. And if you have a perfect square trinomial present, you can take advantage of that and solve some of these quadratic equations much quicker than if you were to use like a quadratic formula or something like that. So really what you're trying to do is you're trying to take an equation like this, which fits into the perfect square trinomial format, that is a squared plus or minus 2ab plus b squared. And this is equal to a plus b plus or minus b squared. If you haven't seen this before, or maybe haven't seen it in the combined format, the plus or minus just indicates that a squared plus 2ab plus b squared is equal to a plus b squared, or a squared minus 2ab plus b squared is equal to a minus b squared. And what I'll say about this equation is it's very useful if you are allowed a note card on quizzes or exams or those types of things. It's worth writing down and taking advantage of. It's really useful. So, and really what you're looking for is that if you see an equation like this, where you can split the x's and a is equal to x, and you split the 4 into two 2's, and you see that b is equal to 2, and then you're just lucky enough to see that where this is equal to 2ab, and this fits into that format, so 2 times x times 2, and you see that equals 4x, and that confirms that this half of the equation here is a perfect square trinomial. Then what you can do is you can rewrite this entire quadratic on this side of the equation in this format. Since there's a minus sign here, that fits into this format down here, and we can rewrite x squared minus 4x plus 4 as x minus 2 squared. And then we leave the 100 here that's left over kind of as a remainder, so to speak, equal to 100. So the goal is that if you ever want to solve a equation and you want to solve it using a perfect square trinomial format or by completing the square, what you're trying to do is get a perfect square trinomial on one half of the equation and then just stick everything else on the other side. Now, why this is useful and why you want to take advantage of this is that especially if you start seeing a lot of values where everything's like perfect squares, like, oh, there's a 4 here, that's a perfect square. If you see 100 here, that's a perfect square. A lot of times that kind of sends out the red flag and says, hey, let's use a completing the square technique here. So, and the reason for that is that now that I have this written out in the new format, what sticks out to me is that, hey, if I take the square root of both sides, one of the things that happens is that the x minus 2 squared just becomes x minus 2, and the square root of 100 simply becomes plus or minus 10. And now you took something that's really kind of a mess and really simplified it out in terms of finding what the solutions of x are. So if you want to find these solutions, I usually just write two pathways. I just say x minus 2 equals 10. And then if we look at the other side and we say x minus 2 equals negative 10, what I'm trying to do here is I'm just trying to find my possible solution. So, you know, I add 2 to both sides. I add 2 here, I add 2 here, and then I get x is equal to 12, and I get x is equal to negative 8. And now I just found my 2 solutions. So you can either write them separately like this, or a lot of times this is more than acceptable in terms of writing your solutions. But I have solutions of 12 and negative 8 for this particular scenario. And this, again, just is another way that we can find these solutions of x. Now, one thing I do want to take a minute to talk about, though, is like, let's say you have an equation and it's not in a perfect square trinomial form right away. You might get a question and it'll just ask you to complete the square, or maybe you'll need to complete the square so that you can solve using the completing the square technique. So in this situation, you'll see it maybe as a question mark, maybe it'll just be a square and it'll say fill it in. What they're trying to do is they're trying to get you to look at this and say, hey, what value, if you got to pick, would you put here in order to complete the square? Because you can do that. So the idea here is that if you can look at this quadratic, like, all right, if we're assuming ax squared plus bx plus c format, you know, we say a is equal to 1, b is equal to negative 1. And what do we want c to be? All right, that's the question of the lesson. So if we are taking this into consideration, there is a format that we use. And this format, just keep in mind, only works when a is equal to 1, right? So don't get all kind of weird with it. It's only when a equals 1. But if a equals 1, what you can do with the c term is that you can always set it equal to b over 2 squared. And this is what you'll always want the c value to be whenever you're completing the square. So since b is equal to negative 1, what we want b equal to is we want to go negative 1 over 2 squared. And if we go 1/2 times 1/2, or negative 1/2 times negative 1/2, this will just equal 1 over 4, because if you multiply two negative numbers, you'll always get a positive number. And this is the number that we would want to inject here into this given circumstance. So the answer that you would want in this given scenario is x squared minus x plus 1/4. All right, and that would be your equation with the square completed. So this is fitting into the definition of a perfect square trinomial, which just means that it fits into the format that we were just talking about, that a squared plus or minus 2ab plus b squared, right? And that's all we're trying to do here is, hey, what value do we want to plug in? Just looking at a second example and kind of just looking at that, let's do this again. So a is equal to 1, so it fits the condition that we needed to. B is equal to 4, and c is going to be equal to 4 divided by 2, okay, because 4 is what the b value is. We square that, that'll be 2 squared, which is equal to 4. Okay, so now we have everything we need. We have the c term. This is, again, what you inject into the quadratic here that's incomplete. And if we say x squared plus 4x plus 4, we have now made another perfect square trinomial. So that's all we're trying to do when we say complete the square is, hey, what value do we need to make this a perfect square trinomial? So now that we're in this scenario and we have this skill, let's move on to actually using an example. Let's combine both skill 1 and skill 2 and actually dig into some real meat here in terms of answering a given question. So, for example, if we have a situation where x squared minus 3x equals 4, what I want to do is I want a perfect square trinomial on this side, okay? So if I can get a perfect square trinomial on this side of the equation, and then I just leave whatever happens as a result on the other side, I can factor the perfect square trinomial side and then leave the remainder. But this is incomplete, like I said. All right, this is what I want. This is the goal, so to speak, is to make this a perfect square trinomial. So if we do that, really what we're saying is going x squared minus 3x plus question mark, just like we did in skill 2. But remember that this is no longer an expression, it's an equation. So what we have to do is we have to use the addition property of equality in whatever we add on this side to try to make it a perfect square trinomial. We have to add to the other side as a consequence. All right, so all we're doing is we're just taking what we learned from skill 1 and skill 2 and we're just merging them together in this specific format. So how do we do this? How we do this is, again, we just check our parameters. We see that a is equal to 1, it fits the condition. We see b is equal to -3. And what we want to just do now is we want to say, hey, c has to equal b over 2 squared. B is equal to -3. So we go -3 over 2 squared. This will give us 9 over 4. And this is our c term. So now we're going to plug 9 over 4 in here, and we're also going to plug it over here because the addition property of equality requires us to. But what happens as a result is now we get x squared minus 3x plus 9 over 4 equals 4 plus 9 over 4. So the perfect square trinomial that we were trying to get here, this has now been accomplished. And so what we're going to do is we're going to go, and the format will always be what the b over 2 term is. So really once we get this, we'll just say x minus b over 2 squared will be the binomial that's formed. But we'll want to write that in like what we actually have. So -3 over 2. We'll square that. And then we'll say 4 plus 9 over 4. What I would do in this specific instance is I would give these guys common denominator. So I would say 16 over 4 plus 9 over 4. And this in all will be equal to 25 over 4. And the reason I'm not converting this to a decimal right away, I want to leave this as a fraction, specifically in this type of fraction format, because one thing I want to see if I'm ever completing the square is I'm looking to see, hey, are there any perfect squares in my fraction? And the thing is that 25 is a perfect square, and so is 4. And this is going to be really important. I'll show you why down here. So if we're looking at this specific format and we say x minus 3 over 2 and we square this and we set this equal to 25 over 4, what's going to happen is that if we square this and we square this, this is the same thing as saying square root of 25 all over the square root of 4. And we will need to go and set this equal to plus or minus that because we're taking that square. But what this allows us to do is once we simplify this out a little bit is we can say x minus 3 over 2 is equal to square root plus or minus the square root of 25, which is 5, all over the square root of 4, which is 2. And now we just, again, took this kind of a messy quadratic here, and we are finding the solutions of x as simple as this. So if we look at one circumstance, we can say x minus 3 over 2. Let's set this equal to the positive extreme. And let's say x minus 3 over 2 set to the negative extreme. And if we add 3/2 to both sides, we'll see that this will be x equals 8 over 2, which would be equal to 4. And if we add 3/2 to this situation, negative 5 plus 3 over 2 would be x equals negative 2 over 2, which would just be negative 1. So your solutions of x would just simply be 4, comma, negative 1. And those would be your solutions given this circumstance. Let's look at one other example in terms of solving an equation by completing the square. Now, I want to point this out. So this is a circumstance where a is not equal to 1. Let's just fix that. It's going to make your life simpler. Just trust me on this. Because the thing is it doesn't really matter how quirky that b term is. So the first thing I'm going to do is I'm just going to go and I'm going to take all these equations and I'm going to divide them by 4. Okay, and I'm just going to rewrite the new equation that results out. So if your a term is not equal to 1, just simplify it out. It's going to make your life easier. Okay, this will give us 5 over 2c equals negative 7 over 4. And now that we have a equal to 1, we have a the way that we want it, what I'm going to do is I'm going to do the same thing that I did previously. Again, keep in mind that the idea here is that we want to go c squared plus 5 over 2c plus that question mark. Really, we're going to try to complete the square, say negative 7 over 4 plus the question mark. All right, so let's figure out what we want the c term to be. The c term is going to be b over 2 squared. Okay, b is 5 over 2 right here. So we'll go 5 over 2 divided by 2. We'll square that. This will be equal to 5 over 4 once simplified. Square that. And then we'll get 25 over 16 as that c value. So again, keep in mind, we're plugging that in there, and we're plugging that in there. So as we go and we chug this all out, plus 25 over 16 equals negative 7 over 4 plus 25 over 16. What I'm going to do here is I'm going to make this with the same common denominator as this. So if I multiply negative 7 over 4 by 4 over 4, that'll give me negative 28 over 16. So now when I rewrite that, I'm just going to put that here. Plus 25 over 16. And this will be equal to negative 3 over 16. So, no, this is a little longhand. What I'm just trying to do, though, is I'm just trying to keep it in fraction form. And hopefully this is something that you feel pretty comfortable with. So now I have my perfect square trinomial over here, which is pretty awesome. And I have this really simple fraction on the other side. So let's take this. This is getting a little bit longer than I like it to, but we can just bring this up here. And if we write this in factored form, we're going to have x plus 5 over 4 squared. So we just took a perfect square trinomial and we factored it out based on the format that we talked about previously. And now this is all equal to negative 3 over 16. And now where this is going to become a little bit more useful is now we square both sides. And this will be plus or minus the square root of the other side. And again, what you're going to notice now is that as we work this through, plus or minus, we'll have the square root of negative 3 all over the square root of 16. And remember that when we're looking at the square root of negative 3, this is equal to the square root of negative 1 times the square root of 3, which, again, remember that this is equal to I, so this is equal to I square root of 3. So now if we want to simplify this out, we just say x plus 5 over 4 is equal to plus or minus I square root of 3 all over 4. And now that we have this given scenario, we can split this apart, we can work the math out, but honestly, because I have the imaginary component, I find it acceptable to just say negative 5 over 4 on both sides and just write my final answer as x equals negative 5 over 4 plus or minus this imaginary component. We're really just writing this in complex number format. And now we have our solutions, our imaginary solutions specifically for a quadratic equation by completing the square. Okay, So hopefully you're able to follow along with that. But this is a technique that you can use for solving quadratic equations. So the last skill I want to go over with you guys is talking about how to rewrite an equation in vertex form. Okay, so vertex form, remember, is this y is equal to a times x minus h squared plus k. So horizontal translation, vertical translation. And so what we're going to do is we're going to just take advantage of, hey, if we can make a perfect square trinomial, we can get this x minus h part. So really what you're trying to do is you're trying to find that axis of symmetry. If you're told what the axis of symmetry, you kind of know what that b term is already. So what I'm going to do here is, you know, I have this situation, and really all I'm going to do here is say y, let's say plus question mark. I think this is just the easiest way to do it. I'm not saying this is the only way to do it, but I think this is the easiest way to do it. So I want to go x squared plus 4x plus question mark. And we can leave the 7 there, or we can move it to the other side depending on what's easiest for you. But just remember that if you want to rewrite something in vertex form, we just want this part. I kind of want to ignore this -7 that's right here. It's not really important right now. I'm just going to find specifically what that c term has to be in order to find the perfect square. And then we'll adjust everything later. Okay, so what I'm going to do here is I'm going to find my c term. And I know my b term is equal to 4, so my c term has to be 4 over 2 squared. Oh, actually, we've done this quadratic before. 2 squared equals 4. Okay, so that's going to get injected here. But remember, this is an equation. We add something to one side, we also have to add it to the other. So what I'm going to do is I'm going to just go y plus 4 is equal to x squared plus 4x plus 4 is equal, or sorry, plus -7. And this is a perfect square trinomial right here. And if we factor that out, we'll have x plus 2 squared. And we can just factor that out. We'll have the -7 left over here. We'll have the y plus 4 left over here. And if you want to put this in vertex form, all we have to do is go back, look at this format, and say, oh, y is supposed to be all by itself. So if we subtract 4 from both sides, what you'll get as a result is you'll have y equals x plus 2 squared minus 11. And now you'll have your equation in vertex form, and that's how you would go about this process. So I hope this video was helpful in encouraging your understanding of completing the square and techniques revolving around that. I hope you have a great rest of your day, and peace out.